All right, time to balance equations. I hope you've got your notes from the first video. This is our second time through, and I ask you to have your notes because I'm not going to pull up the chlorine and potassium bromide becomes potassium chloride and bromine equation that we looked at to identify all the different parts, but I want you to recognize again that that chlorine is a Cl2, not a Cl. There are some important factors when we look at subscripts and we go through. The other thing we want to know now about balancing is that whatever you start with, you have to end with. Again, Dalton's law. So however many atoms are on the reactant side of each element or each molecule, they have to be the same. They can rearrange, but the numbers have to be the same on the product side. And so that is, of course, what a chemical reaction is all about. It's taking chemical elements of this single element or molecule and this single element or molecule, switching them up, and now we have new molecules or new single elements have been liberated, if you will, to put the words. Notice here what I'm looking at in front of me, it says species. Well, because we can have an element or molecules, we refer to the whole set of those as species. But it's simply saying, what is that molecule? What is that element? At our next step, make sure that if you are given a word equation, you translate it carefully. Use the internet, use ion sheets, but make sure you watch out because things like chlorine, you'll think, oh, that's just Cl. No, remember it's Cl subscript 2. It's a diatomic molecule. And those will show up and can mess things up very easily if you're not careful. Potassium chloride, KCl, there's only one chlorine there. So when we balanced, we had to have 2 potassium chlorides. We always balance with the coefficients, the subscripts for chlorine, or the 2 and an H2O of water. When you say it's water, that 2 has to follow the H. You can't change it up and make it 2H2O because then you have 2 hydroxides, and we get to that later. So never change the subscripts. They're part of that species. Let's take a look at an example. I've got propane burning in oxygen. Those are my reactants. They produce carbon dioxide and water. How do I know they're the reactants? Well, the word to produce tells me that the carbon dioxide and the water must be the product side, and the propane is burning in oxygen, so that must be the reacting side. Those are the 2 reacting. Carbon dioxide and water are the 2 produced. So I use my ion sheets, I go through my nomenclature, and I translate this all together. And I find out propane is C3H8. Oxygen, again, is one of those diatomic molecules I have to watch out for. Carbon dioxide, dioxide tells me I have 2 oxides. Dihydrogen monoxide, you could find that name somewhere around, but most of us just call it water, H2O. All right, so I start by counting, and I like to go from the left to the right unless I'm looking at oxygen. Oxygen, it's a single thing, but I've got 2 oxygens on the right side, so I'm going to leave oxygen to the last. I'm going to start with my carbon, and how many do you see? I hope you see 3. So that means I need to have 3 carbons. Now, I'm not going to create a subscript, because then I'm changing, it's no longer a carbon dioxide. As soon as I make it a C3 something, it's a prop something. And so we don't want to do that. We change the coefficient. Notice I have changed the number of oxygens. That's why I'm going to leave oxygen to the end. So I come back all the way to my hydrogen, and then I'm going to say I've got 8 of those. Well, what times 2 equals 8? What times 2 equals 8? Certainly, it's 4. All right, now it's time to look at the oxygens. But I'm not going to just throw in a number here because I've got only one set here, and I've got 2 that I have to account for here. So 3 times 2, because there are 2 oxygens in the dioxide. 3 times 2, help me out, plus 4 times 1. So now I've got 6 plus 4 equals 10. Then over here I've got 5, what do I got? 2 times what equals 10? So it is. And then I come back and I'm like, okay, everything is good and balanced now. So I know I'm only going to have 1 mole's worth of propane, I'll make 1 mole of propane will need 5 moles of oxygen, and I'm going to get 3 moles of carbon dioxide and 4 moles of water. Let's double check this. 3 carbons, reactant side, 3 carbons now on the product side. We've got 8 hydrogens on the reactant side, and 4 times 2, that's 8 on the product side. With our oxygen, we worked backwards, and we figured out, okay, I've got 3 times 2 is 6, plus 4 times 1 is 4, 6 plus 4 is 10. I know the diatomic oxygen, it comes as 2, so what times 2 equals 10? And I put in the 5, and we're good on both sides.